Hello. Good morning, good afternoon. It seems that everything works. Okay, let's get back to work. Last week I wasn't here because I was a little bit unwell. But yeah, I'm back. I did a little homework. I will show you shortly a recapitulation. First thing first, we have signals of the DDR memory grouped into three sections, three groups. The blue group that should be placed on the inner two layer. Then we have green layer, green signals, which should, according to some ST recommendations, be placed on the top, and red signals that as well should be placed on top. It includes the pairs for the commands, for some strobe signals, and not commands, strobe signals, and we have the clock signal that I guess should be placed somewhere to not interfere with the data signals. I created a short list of priorities, and the point number 3 is never mix signals from different groups on the same layer if possible. So we shouldn't mix the DQ signals with the addresses, and we shouldn't mix either of them with commands. But we don't have so many layers, and there is a clock signal which is common to everything, to all the signals. So I didn't find a rule that we should place the command pair, the clock pair, on a separate layer. So we will see. That's first thing. Another thing is that when we check the net classes from the last time, we have a BGA fanout, which is the net class for all the signals that needs to be fanouted from or fanned out from the BGA of the MPU, which is a fine pitch BGA. The DDR is a let's say normal pitch BGA. So to do that, we ideally need to assign all of the signals but the differential pair, because there is a special rule to that BQFO net class. We have two options. Each label can be edited, and when you hit the plus button, there is net class, and you can choose the net classes. But as you can see, we have 15 addresses, then some commands, and we have 16 the data signals. So it's a rather job for a machine, not for human. But there is second option, which is called rule areas. And when you draw a rule area here, it means that all the signals here that goes through that area affects a special treatment. And the treatment is, there is a bug in the KiCad. You can see that when I choose this menu, I can't choose the specific command even before yesterday, I solved it by restarting the KiCad, but it's not the case. We have, of course, everything is in the menu, so place directive labels, which is what we I can't access it. I will show you later. So net class is BGAFO, and we don't have component class for it. And this creates our directive label. So it means that this rule area is driven by the BGAFO net class. So all signals going through the net class area have or has assigned the net class BGAFO. This is a special signal that, naturally, if I create the rule area through the clock signal pair, it will mix the net classes, which I don't want to, and I don't know which is the priority, but the schematic would be mess. The schematic would be, as I said, would be a mess. So it wouldn't be easy to understand what is the net class, and we don't want it. So for the reset, I assign manually the net class, which will be shown here, and the same will be done with the data signals, but we can help by copying the existing rule from the address buses. So now we basically assigned the net class to all signals but the previously assigned differential pair signals. Let's copy it, let's update the PCB, and let's check it, because there is always a chance that it doesn't work. But we will see. So if here is the use net class with, and I choose ground, you can see here on the bottom here, somewhere here, the track width is 0.1. When I route the DDR DQ, the track width is taken from BGAFO net class, you can see. So it works. So there is a trick, and I frankly admit that I haven't used it before, but I will do in the past, in the future, many times. Because when there are many signals with many labels, it's easy to assign the rule area instead of assigning net class to each signal. Thing number 2 is that in the past, I switched all the KiCad windows through the standard Mac OS shortcut, which cycles through all the KiCad windows, which is not very convenient because we always go through this default main window. But I said to myself, well, there must be a better option, and there is. You can see that in the hotkeys, when I type switch, there is a switch to PCB editor shortcut valid in schematic editor, and the same switch to schematic editor in the PCB editor. And so I edited this shortcut was empty by default. So I added the same shortcut, and now when I'm hitting the new shortcut, it quickly switches between PCB and schematic editor. So I believe it's an improvement from the last time. Third things, I activated the net inspector from nets here. You can see here is the net inspector, and I think you can enable it from view panels, net inspector, and probably from I think maybe more places, but I don't know right now. And yeah, additionally, I disabled visibility of some signals because I want to use the red SNES here. And last time we assigned colors to all the net classes, and I switched off the, let's say, normal white net classes coming through the DDR memory or through the group of our rainbow signals, because yeah, I want some clarity, some easy to orientation, easy to navigate area. And back to these rules. I discussed with Gemini for a while and checked some web pages, some Altium guides, some PCBWay guides, yeah, multiple web pages, and I summarized this 5-point list. It's not a general list of rules. This is just my, let's say, helper for this fanout. So what I found is the rule number 1: fanout first, then route, which means that we don't want to route a single track like this, and then like this, and then we are doomed because there is no way how to route this track. Yeah, we can play. So we are, yeah, you can understand. So the rule is, yeah, I don't know if it will work ultimately always, but yeah, all the documents say that fanout first, then route. And because the difficult part is the BGA of the MPU, I will start with the BGA of MPU. Yeah, hopefully, yeah, I switched off the do not disturb. So you establish a target net base. Yeah, I was looking for an answer to a question. What is the, let's say, standard length? What will be a normal length of the routes, of the tracks, and what length we will then use for the length equalization? And the answer from the documents I studied is that I have to establish a target net base of the most difficult to route path. Yeah, that's easy to say, but difficult to do. Obviously, the most difficult to route path can be, yeah, from the first approach, the track that connects the further pad on the left side with the most far pad from the right side. So this will be known, I think, better known after fanout. So this is when, this is why we have to start with fanout, because then I think we will see the most difficult length, the most difficult path. Obviously, if we start with the most right path, you can see that here is the second from the right edge, and here is the 4 row. It's almost the furthest is the fifth 3 is the same length. Yeah, we will see. I think it's not first time right process. We will have to tune, we will have to play with it, we will have to route and delete tracks, but I think the net inspector will help us. Let's check how the net inspector works. So I will start with, yeah, the easiest right now for the short test is DDR-DQ8. So I'm fanning, let's say I'm already routing signal here. Yeah, it's a test. Don't take it seriously, it's a test. So DDR-DQ8. So let's find DDR-DQ8. Here it is, and total length calculated is, yeah, the number is stated here, you can see. So it works. So when I, I wanted to say that instead of calling immediately again the tool of where it is here, route here, tune length of a single track, which show you the current length, and then you can set the target length, and then you can add some silly ridiculous shapes, meanders, waves, etc. So we can see that the completely routed track is calculated identically to the inspector and immediately in the table. When I fan out this signal, DQ11, it's a partial route and still it's visible. So yeah, it works very well, pretty well. So let's start with fanning out. Usually we use the strategy that in the top left quadrant of the BGA package, we fan out like this, yeah, this direction, like direction to the top left corner. In the bottom left, obviously to the bottom left corner. The bottom right, obviously to the bottom right corner, and the last quadrant, yeah, you name it, to the right top corner. So because, yeah, we have a lot of signals, but we can't forget all the signals that must be fan out from the PGA. What I wanted to say? I want to say that if I route this signal like this, and this one, I don't know, like this, or better down, like this, yeah, something like this, there is no way how to fan out this signal. So this tells me that when I disabled all the tracks was too soon, because now, as the rule number 0, or the most important rule, where are you? Here, fan out first, then route. Yeah, that's true, because we have to fan out the BGA package and then start routing. Because when we start routing without all the paths be fanned out, then we can hit the wall, because some signals can be difficult to route or impossible to route, and we don't want to hit that wall. So what I'm doing now is to re-enable all the nets, show all nets, like that. All nets are visible, and then when we will be working with the routing, yeah, when we route the signals, I will probably disable some signals that are not important. But as I can see, I started with Ethernet, which is at the opposite side of the PCB, so yeah, I was not very successful with my plan. Anyway, let's start with these two quadrants of the BGA package, because these two quadrants affect our routing the most. So let's start with fanning out. I don't know what I will comment during this, but let's see. Yeah, let's check again the BGA, the via size. Via size is edited to all the net classes the same way, and we don't use any predefined via. So our default via is the smallest via hole, and how to say, the annular ring size possible. So ideally, we, to avoid the sucking or the wick, solder wick effect, I want to place the via as far as possible from the pad, including the clearance. But this can be a challenging thing, and I think either way, the technology we can check. Yeah, I'm sorry. I still to have check all the things before we start. For first, I am quite nervous from the process. The second, I don't want how I will work while speaking, because this is something I'm completely new to. But yeah, there is still, I think there is a chance to learn a lot. So what I wanted to say that still we will use the plugged or tented vias. I'm looking for that particular setup here. Via covering here, epoxy filled and cap, yes. So it means that the solder wick effect won't happen because the via will be epoxy filled and capped. It means that there won't be a hole inside the via on the bare PCB. The vias will be covered. And in the case, we won't use it. But in the case we will copper pour the ground plane on the top layer, the via would be completely invisible because it's epoxy filled and covered. So the copper plating on top will cover the via completely. The via would be invisible, but it's not our case because we won't pour the copper on the top layer. No more talking. We have to start working on the fan out. So I think obviously via in pad is not allowed, and the clearance can't or doesn't have to be followed or strictly as we discussed a minute ago. So this is our position of the via. It's quite big, yeah, in comparison to the pad, but STM MC3 is not a signal. Why? STM MC3 A18. We don't use the SD. We do. Oh, MMC3. MC2. Where are you? A18. Here. Unconnected, okay. Even better. So now all the rat's nest wires connect the pads that must be connected. Okay. So I will try to fan out all the signals to the edge of the package. Now there is an obvious issue, yeah. How to fan out the inner pads, like this or like this, inside of the pads, or here. It all depends on the target position. Okay. Yeah, as you can see, this will be a lot of fun and a lot of work and a lot of tuning. Frankly, I think, yeah, again, maybe I'm no, green and red on top, okay. So, yeah, I'm thinking out loud, signals from top half of the BJ package, some of them comes to the bottom side of the DDR. As well, some signals, some green signals from the bottom half of the BGA come to the upper part of the DDR, which is where we hit the wall. To avoid future crossings, inevitable crossings, I think I should fan out on the top only the signals that won't cross, and then to use the vias for just fan out to via all the signals that will go to the bottom. At least half of the signals, because when we fan out half of them to vias, then the rest of them can go directly, because we already avoided the crossing, but I don't know. So it means that this should go to via. Let's try this strategy, and what's the worst thing that can happen? The worst thing is that we should, no, this is not that one. This one, yeah. The worst thing that can happen is that we have to rework the routing, which will most likely happen anyway. Okay. Yeah, I studied so-called floor planning for this job, and yeah, what I found is that it's the most difficult job of the job, part of the job, and we have to be careful and work on it. So, what this is the bottom one, so end it in a via. Yeah, obviously, when we change the reference plane, we have to place ground via, but we can't change the reference plane. It means that our into the second layer, this one, the purple one, will be the signal layer for all the signals that has via here, because we can't go to the bottom, because there shouldn't be a return path. So for signals we want to route on bottom, which were mentioned here, the coupling caps only on bottom, not signals. That what confirms that the inner one reference plane is the most important thing, and we have to keep all the signals around this reference plane. So no bottom track signal layers, no bottom layer tracks, no bottom layer signal tracks. Yeah, no bottom layer signal tracks. That's what we must do. Yeah. In the morning, this morning, I have some time for this job, and yeah, that's differential pair. Okay. Yeah. Yeah, understand. Yeah, what I wanted to say is that I thought about starting the job as my homework, and to show you only, to present only a result. But I think it wouldn't be helpful, because you want to see my struggle, and you want to see my my pain, because this is why you are here. No? Yeah, I know you, all of you. Yeah, I have to go here, because otherwise this track would be impossible to route. Yeah, something like this, 1 by 1. This is UDT. This one. Oh. Yeah, I wanted to keep some weight. DQM1 isn't part of the wait. DQ1 is differential pair. No, it's not. Wait. DQM1 please give me a sec.
Yeah, yeah, that's funny. It's funny because I just realized I was on mute. Probably since the phone call, which was like 30 minutes ago. Yeah, yeah. Thank you, thank you. I just realized that I was on mute. Do you know for how long? Because 30 minutes ago I had a phone call, and I'm pretty sure I unmuted myself. But anyway, thank you, thank you. Yeah. Anyway, yes. Back to the signals. Gerbers. We have to see Gerbers because I want to check how many signals from the reference design how many tracks of the reference design from the upper part of the BGA went to the upper part of the DDR3 and vice versa. Gerber? Maybe the PDF would be enough, but yeah, it is like 15 vias. And clearly, this corner signals went clearly to the upper side, and from the bottom to the bottom part, which reflects the intelligence of the package path assign engineer. I don't know how it's called, the function. Yeah, like, yeah, when you assign the chip signals to the package, because you know the DDR3 has some pinout and you want to do it correctly to avoid some unnecessary crossings as we struggle right now. So it means that my position of the DDR3 is incorrect, which means that all of the fan-out signals that were fanned out to vias should be fanned out to routes, and the routes should be anyway. What I have done in the recent 40 minutes must be cancelled, deleted, and started from zero. Yeah. Yeah. Good to know. Good to know. Okay. That's a good. That's a good to know. It's better, isn't it? Now we have a lot of cross signals. Now there is like open windows of signals. Pun intended. Yeah, it literally opened the window. Okay. Okay, so for this, there is a special function. Select all the signals, go to contextual menu, right mouse click, select filtered items, make sure that there is no footprint selected and no other things that you don't want to delete, only tracks and vias, and delete. Hello, D-Lab. Thank you. Thank you for joining from India. How are you in India? What's the weather? What's the local time of your city? It's like 4 p.m., 5 p.m. Thank you for being here. Hi, David. Yeah. Sometimes I think that to sleep instead of yeah, you know what I mean. Thank you for being here. Thank you for watching. So let's get back to work. So fan out first, then route is a good advice, but the even more important rule is check if the rotation of MPU and DDR is optimal. Which means if many signals cross, it means the rotation, not many, majority. If the majority okay. Yeah, a lot of work I have done today. Yeah, I rotated the DDR memory. We are like 1 hour and 10 minutes in the show, and I rotated the DDR module. That's fun. Yeah. Okay. No, obviously not. I corrected the DDR3 signal pair. I corrected the clearance. I verified the via manufacturing. I had a phone call from an insurance company offering me some stupid things. I sent them to hell. They weren't happy. Yeah, a lot of things happened. Okay. Sometimes I think, I don't know if, yeah, something, yeah, more space. Bottom, okay, bottom. Yeah, the thing is that to place the via, I want to be ideally in center. And then to see the entire module, I have to zoom out. What's the step of the zoom? too big. Okay. Okay, this one. Yeah. See how close the reset now is now. That's sign that something good happens in the last few minutes. No, you didn't miss it today. I colored the nets in the previous part on the part before, because obviously you can see, based on my productivity, I am showing up today. Anyway, yeah. You go to layers here, and obviously copper and other manufacturing layers. Then there are objects, like, you can see pads, stupid things, and then nets. And you can see here is a transparency rectangle in front of each eye, which marking the visibility of the particular net. And you can see that here, DDR0, I just double clicked on the transparency piece and chose a color. Because, I made a rule that blue signals on inner 2 and green on top, which is something I haven't been following. So many rules, so many issues. So I'm asking myself, how many rules should I follow? All of them, obviously, but sometimes, So we say, again, that blue signals go on inner 2, which means we'll have via on them, and the green and red will stay on top. Okay, so now there is a newly applicable rule that rules over my old rules. My old rule was to check if the signal goes to the upper half of the DDR memory or the lower or bottom part of the DDR memory module. Now we have the rule that green and red stays on top, Yeah, thank you. Thank you, but now I'm checking. Yeah, now I'm happy. The issue is, yeah, maybe there is an issue with the design itself, besides the issues in myself. There is an issue. The DDR3, no, again, the MPU, this one, okay, was designed for DDR4, which I don't have. We have DDR3L. It means the package pinout is optimal, or was optimally designed for DDR4. We have DDR3. So pinout of the MPU is not optimal for DDR3. That's understandable and it's acceptable. Now, 10 minutes ago, or I don't know, 15, we solved the issue with blue signals. The blue signals that goes on the inner layer. And we can see that the majority of them from the upper half of the VGA package, from here, goes here to the upper part of the VGA of the module, memory module, and signals from here goes to the bottom part. That's good, that's fine. But now I can see that, again, that's majority of the, not majority, but a good half, maybe even slightly more than half of the red signals from here, which who decided about their color? It was taken from some application node. Okay. But anyway, it means that green signals are data signals 0 to 7, so the lower byte, LSB, and the red ones are MSB, data MSB signals. Which is not important. The important thing is that why the hell majority of red ones still goes to the opposite side as I want. So we have to rotate again and try the optimal. I don't know how to I don't know how to qualify I don't know. I don't know how to set the correct rotation. You can say that it's a detail, but not. It's not a detail. It's a crucially important thing, because otherwise This is our yeah, this is DDR4. Yeah. What I'm looking for an answer to my question: what's the optimal position, rotation, angular position of the DDR memory regarding the MPU? Yeah, David. If green and red are on the same layer, it would only look at those when finding the optimal rotation. Yeah, the blue ones will have VIA anyway. That's correct. So you are saying that I should prefer green and red. Yeah, yeah, that makes sense. That makes sense. Thank you. So obviously, we have 1, 2, 3, 4, 5, 6 goes to bottom. Yeah, I will. Do you want me to create a node on the screen? 6. Now 1, 2, 3, 4, 5. We have 12. We have. Yeah, they. Yeah. The LDM is for, yeah, understand. Okay. So we have 9 signals. Yeah, the chat is, yeah, there is a even 5, not 5, I think 1 or 2 minutes lag. Not 5 minutes. Yeah, there is a big lag, but I can't solve it because I'm now in StreamYard, the streaming platform, and I can't see the LinkedIn. So yeah. Okay, so we have 6. Out of 11, so 5 should be, yeah, 5. So, okay. So when the upper corner is, so top left, top right is 5 top, 6 bottom. Okay. And green 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. So it's like half to half. It's not a big deal. And we said that the blue, we won't look at blue. Yeah, maybe if I hide the green nets, maybe it will be less confusing. Yeah, maybe. If we don't look at the blue ones, it means that this doesn't cause crossings in between blue, red and greens. This one is the same as the one in the node, just opposite, half and half. And this one is useless because the top one, red ones, goes to the bottom. So there are crossing. So this one. Yeah. But yeah. It means that all the decoupling caps and other components yeah, I guess. Thank you for confirmation. Now I think all the decoupling and caps and other components must go to the bottom side of the PCB because obviously we need some area for routing. So now I'm going to check. Yes. That's the divider. Yeah. 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 Yeah, because we won't have any signals on the bottom but the power. We can basically place all of them almost all of them, I think. Well, I started routing like this. X. When you hit X to start routing, you can see where the pad signal goes or track goes to. It's a trick I use to see the the distance in between pads, etc. Yeah, just start routing and it will show you. Hello, hello, thank you for being here. How are you? Let's try this. Yeah, I know, but you are right. You are correct. Yeah, that's a good point. That's a good point. Yeah, thank you. For now, I will keep them here, but yeah, you are right. Even on the left side, it's not optimal to place all of them, I don't know, to the bottom side. Why? Because no, it is. My idea was to avoid a lot, like too many vias, but we don't need vias. The power distribution will be done from the bottom, and the ground can be poured on the bottom side. I don't know. As I said many times before, I don't know what I'm doing. I don't know what I'm doing, and I'm doing it slowly. Okay. No, that I didn't want to do. Okay, so let's. Yeah, exactly. Exactly. We will have to start with the most difficult track to route, and then to length equal or equalize all the other tracks. So exactly as you said, but That's why I'm so confused, because yeah. You know what? It's a design stream in my free time, not free time. It's the time I'm not paid for, but that's life. And if it won't work, we can always start over. I mean, I would rather learn myself here for free than in the project of a customer that I would screw up. So let's keep this position and we will see. I will fan out the majority, or I don't know, I don't have much time. I will fan out the signals and then we will see. Yeah, exactly. Exactly. Thank you. I have to say that the fanning out of the signals now is much easier because I care only the color, not where the particular signal goes, because I know that this position offers that all the reds goes to the upper side and all the greens goes here. I think maybe what we can do is to minimize, not to minimize. Yeah, let's say to minimize the length difference, the expected length difference. We should go that visibly the length of the red signals is the same as the length of the green signals. But what with the blue ones? I don't know. Yeah, there is, there is, from the last time, there is a length equalization parameters or limits. Yeah, and I was surprised, and I think I double checked that DQS pair and clock pair is 22 millimeters plus minus, which is, it means you can route it anywhere, and even 3.5 millimeters of all the address and commands. So it means all these signals are plus minus roughly 4 millimeters. So it means the rough difference can be 7 millimeters. So one signal can be 10, and when the other one is 17, it's still okay. Obviously, we want to place the module as close as possible to not work with like 50 and 57, but rather 10 and 17, because as closer we are, the lower probability of the wave action happens. It means that at 50 or 100 millimeter far from the module, from the MPU, we have to care about the wave action because it probably happens. When we are 10 millimeters from the module, even at the same length difference, the wave action probably won't happen. So, yeah. And roughly. Yeah. I didn't mention the most strict, which are DQs and their strokes, which are quite strict, but still we are, let's say, almost 3 millimeters in difference. So 10 to 13 is almost good. Okay, and yeah, I will have to conclude the session soon, but yeah, I'm now playing around here. A test track here, which is 17. Now I need something that goes here. Yeah, it's awful. It's yeah, and it's 20, so 3 millimeters. And this signal is address, so AC, and AC is 7 millimeters. Now we have 20 and 17, so 3 millimeters. We are still within the limits, and we didn't do any tricks, any meanders. So I want to say that if we do it like the best way we can, I think we will succeed. Okay, I like it. I like this. Yeah, if I continue with this one, yeah, obviously it's too short. It's 14, but still there was 20 and 17. So we have within a few millimeters of distance, and we have a lot of space here to make tracks longer. Even here for the green ones, not so much space, but we will have, yeah, in between we have like 4 signals here, 4 signals here, or maybe 5. So yeah, I think we are on the correct track. Maybe I can go directly from the package, but yeah, somehow I tend to make some space here for I don't know what, because all the blue ones will be in the inner layer. I don't know. This is the unassigned, very slow reset signal, so I can place it to the inner layer. Okay. Let me take a. Yeah, I'm not sure if I displayed this comment. Yeah, exactly. Quite forgiving. Let me take a minute break. I need to like move my body a little. Yeah. That's a good question. If you rewind to the last session, you would see everything shortly. I started with Eisler manufacturing constraints, and it showed up that I wouldn't be able to place the via in between pads. So I quite recommend to look at it. If you go to my LinkedIn profile, then in the profile there is a section events, and in the events there are all my streams, or there is a featured section directly in the profile. Featured section there is called like video here, like no posts here, profile. Yeah, you will see my profile. Here is a featured section. Here is KiCad portfolio. And behind this link, there is everything I have ever recorded, ever. And here in this part, you will see in the 16, you will see how I dealt with the manufacturing limits. Or if you go here, events, this is the happening right now, streaming session, or stream session, and here is the 16. So you have two ways how to check it. Shortly, again, yeah, I ended up with GLC PCB. They have a special 3 mil limits for both thickness and clearance for fan out, for BJ fan out. Specifically mentioned that these limits are for BGA, and it's okay for short tracks to use this small clearance and track width, and including the very thin angular ring. So I double checked. Even my friend on who comments frequently on LinkedIn confirms. I think he didn't check it, but he watched the session, and yeah, it seems like manufacturable without any issues. It's the 6-layer high density PCB layout, and all the limits are there. Great. A lot of them are there. A lot of them. Hello, thank you too. How are you? Let's back to work. So this one makes me dizzy. I don't know what's better, if this or this. This or this, maybe this. It's blue, yes. Where is, here is the center, yes. Let's measure it. It's 22. Why? What is 10 millimeter package? No. Yeah, 11 millimeters. It's a small package. It's a tiny package. Really? Okay, 11. So half is 5.5 here. No, here. Here is the central. 21 is central. So this should go here, this way, and all the signals below goes this way. I'm using, as you can see, the long hairlines for the cursor to align all the vias with the vias at the top. Yeah, here. With this via, I can always align using the long hairlines, which is why I always recommend using thin hairlines, because it helps on multiple levels. There is, above this, like here, there is a crowded space, so I will create some space for the signals in the inner layer. Yeah. Still, it will be difficult. Yeah, even here, I think I should use this direction, because you just can't create an array, a dense array of vias, because otherwise you can't route the signals. Yeah, and see that there are still clearances, and you must be careful. What's good is that we can easily go in between vias in all directions. So it means it's correctly chosen, not correctly, like, I mean, the manufacturer wouldn't complain, but it means that all the limits are set, that we have comfortably, we can comfortably route the tracks. Here is the clearances, track widths according the impedance calculator, and here is the via size. Microvia, don't care the microvias, because microvias are not supported here. Yeah, default must be 0, okay. Okay, what else? something like this. 4, 5, 6. Yeah. Maybe, I don't know. Okay, okay, I'm tired. Thank you for being here. First things, not first, but last. If you want to support me, I created 2 courses on Fedival. First one is called KiCad for Beginners. Essential course for all the beginners who wants to start with KiCad. We will design this PCB, which is power supply PCB, switch mode PCB, and there is a special promotion. If you enroll the course, you will receive a coupon you can redeem at nextpcb.com, and nextpcb.com will manufacture the PCBA for you, not only bare PCB, but the entire assembly. The same for this course. You will design or learn with me how to design this PCB with dual core Raspberry Pi MCU, 2 power supplies, a bunch of things, M2 connector, USB Type-Cs, everything is there. Again, if you enroll the course, you will receive a coupon you can redeem at nextpcb.com, and they will manufacture the same board or the equivalent board, and you can pay with the coupon. And as I calculated the price, the component plus PCB was like $100 plus minus ballpark. And if you enroll the course for the online version, in the online version, the price is even lower than the material you will receive. So that can be a good offer. If you want to support me, buy a course and I will be happy. We have some last comments. Yeah, it's the most finest route, and yeah, you can see that I fight for each hundreds of millimeters. So yeah, it gives me flexibility with placing the tracks and even vias. Yeah, sure. That's my playground. I can make mistakes, learn something, and communicate with you as my followers. So thank you. Thank you for being here. Next week it will be on Thursday probably, because on Friday I will be traveling. So see you in less than a week. Thank you for being here. If you want to support me, as I said, consider enrolling a course. You will receive coupons for the manufacturing. It's a no-brainer in my opinion, but it's up to you. Thank you. Thank you. No new questions, no new comments. It was a lot of comments today. I'm very happy. And we moved the layout a little bit closer to the finish line, but not much. It's a process. Thank you and see you next week. Bye.